cylinder is very easy, same as hollow sphere, that is also easy. So let's just discuss that, and if there is time I will do some questions, or in the next video I will do some questions. After this I will do solid sphere, a JEE advanced question where you do not have to know how to do it, just knowing the dimensions will be enough to do such type of questions. So overall this part is enough. The major part you have to know is lambda is equal to m by L, and sigma, which is areal density, that is linear density, which is equal to mass by area, and volumetric density, which is mass by volume. Just knowing these parts is mostly more than enough. Like you would be able to do it in like dimensional analysis way, like you can check dimensions and do it. Anyways, let's get to today's topic, hollow cylinder. Right, I haven't taught, I guess, rings, but you would be able to understand. For hollow cylinder, can we not just take that let's consider a small ring of radius r. Every place the radius is r, guys. Yeah, so for this small ring, on that place can I consider the mass to be dm? Of course I can. And if we just tag the rings like that up to there, it would form a hollow cylinder, isn't that true? So what we have to do is just integrate it. That's it. From where to where? Let's consider this to be some 0 and here to be some length L. From 0 to L we have to integrate it. Since it is kinda, I'm giving a question, let's consider the density is density not x, areal density. Some kind of some question this is. So now we have to find it. What do we have to find? We have to find, let's say, mass. Now that since we are considering small dm, and that means some sigma of function x, yeah, is equal to that dm by da. Yeah, up to here everyone is able to get it, I hope so. And da equal to length into thickness. Let's say the thickness up to here is some dx. Let's just consider that, and the length is L equal to r theta. Theta is 2 pi, so 2 pi r. So dA equal to 2 pi r into some dx is the dA. Now we have to just find dm. So dm equal to sigma of x into dA, which is basically dm equal to sigma of x, yeah, into 2 pi r into dx. Did I keep the radius as r? My bad. This is r, yeah. So just integrate it, it is fine. So the total mass, which is m, sigma naught 2 pi r, some constants, r is also a constant, I just took it out, from 0 to length L, x into dx. The integration is easy. So mass equal to sigma naught 2 pi r L square by 2. So that mass is basically sigma naught pi r L square. I mean, these are like valid questions, but this is not really testing any physics, so I'm afraid the JEE Mains might not ask these type of questions. So this is how we do for hollow cylinder. We just the major idea is we just consider it as some ring and we stack those rings until the full case. That's it. And after this hollow sphere, after that the question from JEE Advanced, solid sphere, and after that few questions. So yeah, for this session I think this part is very fine and it is enough. Sure, I think I will just do if the video does not fit. Like I have a restriction that my videos can only be like 10 minutes long, and so yeah, let's see if I can fit it over here. Let's consider a hollow sphere. This hollow sphere, since I cannot show it in 3D, which is my bad, can you not all just think of it like a ring here, a ring there, a ring there, a ring there? Like rings are all stacked up on each other. Like we can consider that, but here it has equal radius. Here the radius is not equal. That's the only difference. Let's say that is the axis, and let's consider this part, a small ring. This is also, yeah, some d theta, some theta. So for this small ring, the length is r into d theta. What do you mean by the length? Not the length, the length. The thickness is r into d theta. Then what is the length? Length is basically L equal to r theta. R is some variable, but for every piece the thickness is r into d theta. Like this small ring, r into d theta. The thickness is same, r into d theta. The thickness doesn't change, but the length is variable, and let's consider that variable unit as some r. So this is at some r distance. A small ring is there, and we have to integrate it. From where to where we have to integrate it? Let's see. Let us see which function we are going to get first. So L equal to 2 pi r. R is a variable, guys. R is a variable. Acha. So bad at drawing diagrams, my bad. Some r ring is there. Yeah. This is some r. Let's consider this some theta. Now then, let us let's say this is some perpendicular, and this is 90 degree. This is 90 minus, sorry for the diagrams. Okay, I will never improve on my diagrammatic skills because I'm literally not interested to. So r, some ring, the length to that ring is some r. Since this is theta, this is 90 minus theta, right? Yeah, understand the explanation, guys. So for that ring, the r is some r, and this is radius, which is r, and we want in this direction, which is r sine of 90 minus theta, just vector resolution, which is sine of 90 minus theta, r of cos theta. R of cos theta is that r. So we got the variable unit r as some r cos theta. So why did I break my mind to be able to find that one? Very simple. And let's say that the density is some sigma again. This is areal density because it does not have volume. So that sigma equal to dm by dA. dm equal to sigma into dA, and we got that the thickness is r into d theta, and the length is r 2 pi r, and r is r cos theta, which is 2 pi r cos theta. Yeah, my problem is solved. So the dm is sigma dA 2 pi r square into cos theta into d theta. The function is theta, guys. So from where to where do we integrate? This is minus pi by 2, negative pi by 2. This is positive pi by 2. That's it. That's where we have to integrate. So if we integrate from 0 to total mass, which is m sigma 2 pi r square, and if we integrate this, my negative pi by 2 to pi by 2 of cos theta into d theta. That's it. Just integrate, guys. This is how we do these type of questions. And in the next section, I will be discussing solid spheres. That question I found from 2016, I guess, or I don't remember, some advanced question of a solid sphere. And another session I'm just going to discuss like a few questions to be able to better understand on how to take elements, on where do we take elements. That's it for today's session, guys. Thank you.